This topic will be about absolute value inequalities. And we have talked about two topics individually at a time. One is the absolute value equations, and the other one is the inequalities. With absolute value, we must consider the number of cases, which is possible to have two answers, one, or possibly none, which will give us a no solution. Now, the inequalities must include the solution, the graph, and the interval notation. So I'm going to go over how to put it all together, which is the absolute value of an expression less than a value. So here I have a question which is solve for the absolute value of x minus 2 less than 3. The fact that 3 is a positive number, it tells me that I have two possible cases. So in order for us to split this one in the best case scenario, so it's the same or similar expression as to say that x minus 2 is between positive 3 and it's also between negative 3. So if you remember from class, this is the topic that we have covered. So when we have an expression in between two inequalities, and we're going to isolate for both of them at the same time. So we have to solve for x minus 2, adding 2 to the other side, but in this case we have a third side, so then here we're going to say plus 2. So when we do this, we have negative 1 is less than x is less than 5. So we're saying, okay, x is in between both of these values. So x is in between negative 1 and positive 5. So now I must show my graph. Remember that when we have our graph, we have a 0 here, or negative 1, and my positive 5 right here. And we're saying x is in between these two values. And between these two values will be here. Now the fact that we have less than, that means that we have parentheses. So x is less than 5, but x is greater than negative 1. So then here we have the parentheses in the other direction. And lastly, to write my interval notation, then we'll read from left to right. So that in this case, we're going to have from negative 1 to positive 5. Close bracket. And that's our final solution in this case. I'm going to continue with the second example, for which, let's say, for instance, I ask you, let's solve for the absolute value of 2x minus 5 close for the absolute value plus 2, and then in here I'm going to do less than 9. Okay, less than 9. So in order for us to start solving this problem, we have to make sure isolate the absolute value first. So in order for me to isolate this absolute value first, I must isolate for the absolute value by subtracting the positive 2 on both sides. So let me start this problem here on the side. So then here we have absolute value of 2x minus 5 plus 2 less than 9. So in order for me to start, I need to isolate absolute value. So we said that we have to subtract the 2 both sides. Once I isolate it, I'm going to have 2x minus 5 less than a positive 7. So since we have a positive 7, that means that I have two cases. So the thing about being less than is represented by saying this is a similar statement to enclose this expression, 2x minus 5, by one side to be less than 7, but is greater than negative 7. Once we have this case, then we're going to continue and isolating for our x, which is in the middle of these two values, negative 7 and positive 7. So I must add a positive 5 on both sides. Once I have my positive 5 on both sides, this one is going to turn out to be negative 2, less than 2x, less than 12. Once I have this one, I still notice that I have to divide everything by 2. So two sides, divide by 2. And lastly, in here we're going to get negative 1, less than x, less than positive 6. So this is my solution. Once we have the solution, now we can graph it on our number line. So I have a 0, I have a negative 1, and I have a positive 6. So we're saying we are in between, or x is in between these two values. So we have in between is less than 6. So we have to use a parentheses, but it's greater than negative 1. So in here. And lastly, we have our interval notation. So my interval notation says I go from negative 1 to positive 6. Both cases, right? I'm going to continue with a third example. So on my third example, I want to solve the absolute value of x plus 2. And now I'm going to reverse the sign of saying greater than positive 4. Now, when we're on the greater side, then here this one turns out to be similar statement as to saying or, like the union of two equations. So in here, the fact that 4 is positive, that means that we have two cases. So my first case will be x plus 2 greater than 4, or x plus 2 is less than, and this is when we change the direction of our inequality, and when we change the direction of inequality, we change the sign on our value, the positive and the negative 4. So very important that we don't forget, reverse this sign and changing the positive 4 to a negative 4. Once you have those two cases split up, then again we continue solving like any other regular equation. So we're going to say minus 2 both sides. And when we say minus 2 on both sides, that means that I have x greater than 2. And this is it for this side. And the other side will be minus 2. And in this case, we're going to have x is less than negative 6. Now remember that the fact that we have or it represents a union in between these two equations. So I still have to show my graph. I have a 0. I have a -6 in this side, on the left side. -6. And on this side I have a +2. So one of my graphs says is greater than 2. So in here I go to the greater direction. And it's greater, that means I have a parenthesis. The other inequality says x is less than -6. So less is on this direction, and it's also less than, so that means that we have a parenthesis in that direction. So now, the last thing for us to do is how to write it in the interval notation. So the interval notation says I start at my -infinity, parenthesis and -infinity, and the purple line goes up to -6, parentheses, and then I have a gap that starts again in +2. Remember, we have an OR, that means it's a union, so we're going to do a union, and I will continue from 2 to +infinity. And close. I will continue with another example. So here we're going to solve for, and I'm going to throw a fraction one. So we're going to say solve for the absolute value of 5, multiply to x minus 3. My pen sometimes doesn't work nicely. Divided by 2. Absolute value of less than or equal to 0. So when we have less than or equals to 0, remember that we must consider here, right? This value is a 0. So do we have 2 cases, 1 case, or no case? So we talked about this one in the previous lecture. We said that 0 does not have a sign. It's not positive, it's not negative. So this leaves me with 1 case only. So in order for me to remove this absolute value from here, it stays the inside expression as just to continue with 5 times x minus 3 divided by 2 less than or equals to 0. So pretty much it stays the same. Nothing happens. I don't have to worry about considered cases or not. Now in order for me to continue moving on, remember when you have fractions, remember that the way for us to remove a fraction is, okay, so first of all, we don't freak out, we don't worry that we don't remember how to do it. You multiply by the opposite of 2, right? I mean, yes, because this 2 is multiplying, so that means that we're going to multiply both sides by 2. Multiply both sides by 2, so that way we could cross out these values. So you cross these 2 out, and we're gonna get 5 multiply to x minus 3 less than or equals 0 times 2 is 0. I continue, so it says I have to continue with my distributive property. So when I continue by the distributive property, it says that I have to multiply this 5 to the entire expression. So when I multiply this to the entire expression, I'm going to get 5x. 5 never turns out nice. Minus 15 less than or equals to 0. And then we'll continue by adding 15 both sides. Add 15 both sides. And we get 5x is less than or equals to positive 15. And the last step is to divide both sides by 5. Divide both sides by 5. And we will divide both sides by 5. Then I have my last answers to be less than or equals to positive 3. So once you have this solution, the next step is to graph it on our number line. And that means that you have a 0 and my 3 also on the right side. And we have x is less than 3. So x less than 3, that means I'm going to highlight towards the left. And when it says less than 3 or equal to, then we must include our bracket. And lastly, we have our interval notation. So remember, my interval notation goes from the smallest value to my highest number. So here, we'll start at the negative infinity to positive 3. Parentheses and infinity, bracket at 3. Lastly, in this topic, I want to cover two special cases, because I call them two special cases because they seem simple, but then at the end it turns to be a little bit confusing. So we're gonna call it two special cases. They turn out to be quite too simple or too difficult, whichever way you want to interpret it in this case. Now, what I mean by this one is, let's look at the difference between these two cases, or let's maybe call it two cases, two scenarios maybe, about inequalities. So let me ask you this. So we've been looking at absolute value expressions that are less than, right, in the direction, a value. So for instance, in here, what about if I say x minus 3 is less than negative 5? And what we remember from regular equality equation, absolute value equations, is that this number where we have the negative 5 must always be positive. But what about if we compare, let's say, what about we compare it to the absolute value of x minus 3? And in this case, I'm going to say greater than negative 5. So here, we may say, okay, so this ones look about the same by the fact that we have this inequality for that direction, or this one is pretty much a question that we must consider. So in this one, in the first one, right, when we look at this one, we must consider, so here we're saying, let me tell you what I was saying. So we're saying the absolute value of an expression is less than a a negative number. So in here, I'm looking at the absolute value is less than negative. So if you really think about this expression, okay, this sounds impossible. Absolute value can never be less than a negative number. So in here, just by the fact that it says this one, we'll say this one is impossible, right? So this one, we're gonna say impossible. The absolute value must be greater or equal to a positive number. So this one is impossible. So in here, we will say no solution. Now, if we look at the other case, the other example that we're comparing it to, now in here, you will really think about this one, what is it telling us. So, and this one is telling me the absolute value of an expression is greater than a negative number. So in here, I'm saying the absolute value is greater than a negative. So in this case, when is this possible? Well, this one turns out that is always possible. So for instance, in here, you can say, in here, I'm just going to say always possible. And remembering here, your solution will be our real numbers. Right? Our real numbers. So for instance, in here, one way for me to show you this one is, I'm going to show this one by using any random number that we assign to the x. Say maybe x is equals to, probably let's use a negative number, negative 15. So now in here, I want to show you that if we pick a negative 15 and use it in this expression, it would always work. So, in here, so for instance, let me show you what I mean with it. So in here, my absolute value is the negative 15, so I'm going to write negative 15. And negative 15 minus 3. When I simplify this left side, should work. So this one should be the absolute value of negative 18 is greater than negative 5. And when we simplify for the absolute value of negative 10, is positive 18 greater than negative 5, which in this case, this turns out to be correct. Okay. Since it is correct, then I notice that we already said our real numbers. So remember, we say either our real numbers, or you write the interval notation as the negative infinity to positive infinity as your final solution for this case. Now this one, if you will pick, let's say the negative 15 on this side, you will notice that you're going to switch the opposite sign. So in here we said there is no solution, or you say the empty set. And this is all for this section.